95, and that is on page 320. It's entitled Advertising. A model for consumers' response to advertising is given by 2000 plus 500 natural log A, where A is given to us as greater than or equal to 1. N of A is the number of units sold. I take notes. Number of units sold. Fine. A is the amount spent on advertising in thousands of dollars. So A equals 1 represents $1,000. So it's the amount spent on advertising. So amount spent in thousands. Okay, perfect. How many units were sold after spending $1,000 on advertising? So what am I asked here? How many units were sold after spending $1,000 on advertising? What should I do?
1,000.
Very good. Just plug in 1,000. Because it's 1,000, I will plug in 1. Because A equals 1 represents 1,000. So N of 1 is N basically of 1,000. So this is 2,000 plus 500 times natural log 1. Anyone remembers how much is natural log 1? Natural log 1 is 0, so the answer is 2,000 units. So that's it. That's another of those minor properties. The big properties are those three that I mentioned. These are the major properties, but there are tiny properties here and there, like natural log 1. Log in any base of 1 is 0, always. Part B. They're asking us to find n prime of A and n prime of 10. So in part B, they want n prime of A, and after that, n prime of 10. So let's determine n prime of A. When I differentiate a constant, what do I get?
Zero.
Perfect. So 500 stays times, when I differentiate natural log of x or natural log of A, what did we say we will get? I know that this is new, so we get 1 over A. So the answer is 500 divided by A. Because I'm asked to find n prime of 10, n prime of 10 will simply be 500 divided by 10, which is 50. What is the measurement unit? So n prime of A as the answer in general will be, so n is number of units, so we wrote that here. But n prime of A in general, what will it be? Or if you want to say n prime of 10, what will it be? The answer is 50. But what is the measurement unit for 50? Remember, it's a rate of change. Yes. So this is the rate of change of number of units per $1,000. Because A is in thousands. So always remember the rate of change has to have two measurement units. One from the function divided by the one for the variable, the independent variable. It says find the max and minimum values if they exist. So let's find maximum or minimum or both. So let me go to question C. And of course it's not going to stay. Okay, so question C, find max min. So that's the question. So Obviously, a is a number, we are told, greater than or equal to 1, which represents greater than or equal to 1,000. So when I start my table, I get 1 here. I don't want to write infinity, but it's not the case, but you know what I mean, 1 to infinity. So I have n prime of a, and then I have n of a. So let's take a look at n prime of a, which is 500a. What type of number is this? For any a that is greater than or equal to 1, what type of number will it be? N prime of a.
Did you say that again?
Yes. So I'm trying to establish the sign, and then I'll ask you about critical numbers, or maybe I should ask you about critical numbers first. So critical numbers come from n prime being undefined, or n prime of a equals 0. Which one in this case will not produce critical numbers? The undefined or the equal to 0?
Equal to 0.
Exactly. That's not possible. It's a fraction. The denominator cannot be 0. The numerator will never be 0. It's 500. There is no variable in there. So no critical numbers come from n prime being 0. Awesome. But when it comes to undefined, yes. Right? At 0, but 0 is not there. Sorry. I would have said 0, but no. We have to start with 1. So nothing. So no critical numbers come from any. So then that's why, without saying, I directly ask you about the sign, because that's all we need. It's never 0, it's never undefined. So then what do I write? About the sign of 500 over a. This would have been correct if the starting point were 0, but the starting point is not 0, so there is no need for undefined. So what will be the sign of 500 over a when a is from 1 to infinity?
Positive.
Very good. So now I go to this function, and I plug in 1, and we already have that. So we get 2,000 units here. And when a approaches infinity, this will approach infinity. So this will also go to infinity. So what have we discovered about this function? What kind of point is 1 comma 2,000? This is not a point. Infinities are not points. They are symbols. So then what is our conclusion about 1 comma 2,000?
It's a minimum.
Very good. This is the absolute minimum. And the function is increasing all the time. Absolutely. Perfect. Is this a relative or a local minimum?
I think it's local because it's...
Remember, no local or relative at the end points of the interval. So let's write that note again. I was trying to trap you, sorry, because I wanted to discuss this. No local, also called relative, min or max at endpoints ever. It can be absolute, but not relative or local. Good. So there is also part D for this problem. They're asking us to find the limit as a approaches infinity from n prime. Limit of n prime of a as a approaches infinity. I'm going to copy it here. Limit as a approaches infinity. And n prime was 500 divided by a. I took it away, but that was n prime of a, 500 over a. So what do you think about this limit? as A increases without bound, gets bigger and bigger and bigger and bigger.
Change is going to get smaller.
Very good. Very good. Yes, because y equals 0 is a horizontal asymptote. So now here's the question. Great job. Who said that? Was it Lake?
Yeah.
Thank you. Here's the question. Discuss whether it makes sense to continue to spend more and more and more and more on advertising.
No, because at one point you're going to be spending more than you're ever going to be
No.
selling.
Very good. No. Very good. Because the rate of change will not increase. It will get closer and closer to 0. The rate of change of number of units per 1,000 spent will get closer and closer to 0. So the rate of change of number of units per $1,000 spent will approach 0 eventually. Very good. Well done. Okay, do we want to go back to other problems? I mean, I'm going to review this with you after the test a little bit next week. So, just to give you more information about, or you will choose more problems. Any other questions here? I have 15 more minutes, and I'd like to spend them on chapter 4, actually. Anything you would like to go back to? Let me give you another chance to say, yes, I want to see something else, or